So what I'm going to do now is I will present to you a new possibility of how reality is structured, okay? All right, so to begin, let's talk about Kant. Immanuel Kant was the greatest philosopher who ever lived, the most influential philosopher who ever lived, because he introduced us the idea that we are not observers of reality, we are participants in reality. All right? So let me explain what he means. For Kant, there's the noumena. The noumena just means reality that is outside of us, the things in themselves. What he tells us is we can never know the noumena. We can never know this reality. Why? Because whenever we see reality, we filter it using time and space. Okay? So time and space do not exist outside of us. They are part of us. We use time and space in order to interpret reality in a way that allows us to make sense of it. Okay? So the noumena for time and space becomes the phenomena. And that's all we see, the phenomena, the things that are to me, not the noumena, the things in themselves. Okay? And so we imagine reality. We hallucinate reality. Okay, but of course, this creates three problems. Okay, the first problem is, what is the noumena? The second problem is, why do we have these filters, time and space? The third problem is, how can we guarantee that what I see is the same as what you see? Because if reality is a subjective experience, then in theory, everyone should see it differently. But we all see it the same, okay? So why is that? So these are the three problems. And so what happens is that Hegel comes along, okay? Hegel, another German philosopher, and he explains the idea of the geist. So what he's saying is that the noumena, it's really the spirit world. It's the geist. And when you do this, it solves all three problems, okay? The noumena you can never access because it's beyond us. It's a geist that gives us time and space. And as a result, because it's all coming from one source, we see the world in the same way. Okay? All right. So this sounds complicated, but let me now use quantum mechanics to explain what this means, okay? Let's talk about quantum mechanics. Okay, so in science class, you're taught the Neal-Bohr model of the atom. Okay? It's a simple model. You have the nucleus, and then around the nucleus, you have these electrons that orbit the nucleus. Okay? You're taught this in physics class. If you are in more advanced physics, you will taught that it's actually an electron cloud. Why? Because we never know for sure where electrons are. So we can only know the probability of where they are in orbit, okay? So it's called an electron cloud. And this is what you're taught in school. When you go to university, you will be taught this is completely and utterly wrong. Why? Because this assumes that these atoms are matter, they're solid. But in reality, if you go deep enough, you will find that they are actually just vibrations, what we call quantum fields. And they are just vibrations. And what the electron really is an intersection of these quantum fields. Also, these quantum fields can always exist in two states. The first is as a wave. The second is as a particle. Okay? And we can only know if it's a wave or a particle by observing it. And this is what's called a wave function collapse. In other words, all of nature is vibrational. It's energy. And it's only when we observe it, when we interact with it, that becomes something solid that we can see and measure and touch. Okay? It's called a wave function collapse. Okay? So, this is complicated. So, a physicist named Ernst Schrödinger, he creates a thought experiment called Schrödinger's cat. Okay? You may have heard of it, Schrödinger's cat. And so imagine a box, and inside is a cat. And in the cat, inside the box is also some toxic chemicals that may or may not break. If it breaks, the cat dies. If it doesn't break, the cat's still alive. And what Schrödinger teaches us is that when the box is unopened, we can never know the state of the cat. It's only when we open it can we know it's dead or alive. But before then, it's both dead and alive. Okay? That's simple to understand. But then another physicist introduced a new concept called the friend experiment, or Wigner's friend. And this is more complicated because he says, okay, if you are the experimenter and you open the box, you now know the state of the cat. But what if you're a friend? Okay? You don't see the box. You're outside the laboratory. When the experimenter opens the box, does the wave function collapse? And the answer is, it does not. Okay? It does not. And what this is telling us is there is no objective reality that exists outside of you. When the experimenter opens the box, the wave function collapses for him, but does not collapse for the observer and for anyone else. We have to open the box ourselves in order to see if the cat is alive or dead. Okay? But what if this person tells us? The answer is, it still doesn't collapse. We have to participate in the reality ourselves. And what this is saying, okay, this is hard to understand, is that everyone lives in his or her own reality. Everyone has a unique universe onto himself or herself. And that's what quantum mechanics teaches us.